Good morning to everyone. I hope all of you are safe at home. I welcome you all for the webinar on data science and introduction on behalf of our college Sri Kaniga Parameshwari Arts and Science College for Women. I take this opportunity to thank our management committee, our honorable correspondent Mr. Gugilam Ramesh, Vice Principal Dr. P.B. Vanita, and our beloved Principal Dr. T. Mognastri, and Vice Principal Academics Dr. M.V. Napinai for supporting us in conducting this webinar. It is my pleasure to welcome all the participants and the resource person, Mr. K. Satish Kumar, Technical Manager working in a CMM Level 5 software company. He is having 14 years of experience in IT industry and worked on variety of Java projects from development to maintenance. Thank you for accepting our invitation, sir. Now I request Mr. Satish Kumar, sir, to take over the session.
Yeah, thanks everyone. Good morning everyone. So hope you are all safe in this pandemic situation, and I'm very much thankful to everyone to join this session to know about the technology in this crisis period as well and your learning aspects. So let me start sharing my screen.
Yes, sir. Yes, sir. Just a minute, sir.
Yeah.
Sir, your good name, sir? Satish.
My name is Satish Kumar. Satish Kumar Kulandeswar.
Okay. Okay, sir. Okay, sir, you can proceed, sir.
Still, I'm not able to share my screen.
Okay, sir. Yes, sir.
Yeah. Everyone able to see my screen? Is it visible?
Yes, sir, it's visible.
Okay, thank you. And I'm also audible. My audio is clear. Okay.
Yes, it's audible only, sir.
Thanks for confirming. So today we are gonna see about big data. So what is big data? So it's not like the data is kind of a big or something else. So it's one of the technology, or it's gonna be the phrase that we can say where we dealt with data, enormous of data, and how to process it, how to transform it, how to visualize it. So this all comprises of big data. So before starting on the big data, I want to take everybody through the evolution of data, how the data comes upon on our life and how it is being evolved over the years that could reach this technology. So this is the evolution of data. So if you know everyone, I mean, started to write something on your notepad or your paper or anywhere, that's a data. If you write your name, your write on your details or personal details, everything, that's all data. And post that, when the computer comes upon, you start writing upon in your notepad or your Word or anything else, and you store it in the file system. Those are also your data. So those were called as traditional files. Your files in the rack or your files in the system. So all called as data. So these traditional file systems, whatever is there, I want to fetch some information about the data. You have to go and search your whole system, your CPU, and you have to search for that file name. Then you have to get the data. Still, you don't know what that file contains, what kind of data it contains. I would have saved it in a different name, in a multiple data across the same file. So it would be confusing for us to get the data. So that's what the prime objective of data is. Like, I want to go on review back whatever I have entered, right? So in the traditional file system, that is not possible. It is not hierarchical. It may not be a structured one. Like it may be a structured one, but it's not a searchable one. It is not indexed. So these are all the problems we faced in the traditional files in the early days. So then comes the DBMS, which is called as Database Management System. So this is a data that can be stored in a file system in a structured way, in a hierarchical way, but it still allows duplicate of data, right? If you take an, for example, the Excel sheet, I can enter a data at the first row, the same one, in the 50th row, the same one. So it can have a multiple duplicates in the same file. So these are all stored in the same file system only, but with duplicates of values it will be there. And if you still want to go and search it, you will get multiple records, which you may get a confusion, or it may create an ambiguity over the data. So that's where the DBMS comes in. But still, it resolves a lot of things from the traditional file, where you don't want to go and look out many files, at least a single file where it contains all the data. So it's called as not a normalized source of data. They're denormalized data actually. So if I go and say an example, like I have a student who is studying in a particular department, and these are the subjects that he scored a mark or something else. Then again, I want to put him in the practical lab for his subject scores and everything. Again, I have to put his name and I have to enter the data. So that keeps on repeating on the same file system. So when I go and search for it, it creates multiple duplicates, and you are not able to get the results whatever you decide for it. So that causes a delay. So there is a performance issue as well. So there comes the relational database management system that came in 1980s. So what is the relational database management system? It's all like OLTP. They used to call it as OLTP, that is online transaction processing. That's what called as RDBMS, where it contains the relational data. I can store the data in a tabular format, rows and columns. But in DBMS, even you can store it in a rows and columns. These are stored in a tabular format. Like I can store a particular employee name, employee details that I can maintain in a separate table. Then I can maintain their personal details, or the department they are belonging to, or the subjects they are going to take. All those things I can maintain in a separate tables. But I can relate all this information through a unique identifier. How I can just go and identify it? They have an unique identifier that is called as employee ID. That will be unique across everywhere, right? A name cannot be a unique one. His date of birth cannot be a unique one. Even the same name, same date of birth, many people would have been there. So it will be confusing to search across, and it will cause an ambiguity. So there comes the unique identifier, which is called as the primary key in the relational database management system. So with that, you can have the data in a multiple table that doesn't allow duplicates, and it will allow you to get the data from a different table using a relation through the unique identifier. Okay, so that comes the RDBMS, but still that also has a lot of disadvantages and complications, because it cannot store a huge data in a single file system. If I want to put this database in a different location and I want to access the data, still that is not possible. I mean, a single database that has to be maintained somewhere in a single system. So then from there, that has been evolved to OOP, that is object-oriented programming model. So where object is being formed, contain the data through its each and every properties. Like an object property is like employee is an object, where I can store his properties like name, employee ID, his whereabouts, his details.
Hello.
Hello. So he can have his all attributes being entered in a particular object. So that's where comes the object-oriented programming. So it does not need to be stored in any database in a tabular form or in a file system anywhere. There comes the programming model, Java, C++, and other object-oriented programming languages, which could store the data in an object. So it also been easy to get the data, search the data through its identifier, own identifiers, through multiple APIs that has been developed in the programs. After that, it's been evolved to data warehousing. Data warehousing is completely a data ocean. It contains a huge set of data from multiple sources. I cannot maintain a single database for a company A in a single location when I'm going to start a branch B in a different location. I want to get all this data. So I cannot go and transfer all this data to a branch B and where I can see what is there in branch A. So there comes the data warehouse. It can have the multiple sources in a single place. That is called as data warehousing. So this data warehouse is called as online analytical processing. So using this data warehouse, the people can generate multiple reports because I have a branch in Adayar, I can have a branch in Paris, I can have a branch in USA, I can have a branch in Andhra, I can have a branch in Mumbai, anywhere. But all these branches are belonging to me. So I want to get a revenue of my whole company. So I cannot go to Andhra and get the report. I cannot go to Chennai to collect the report. I cannot go to Srinagar to collect all this report. So I need a system, a place where all this data can be collated and generated a report that could show an analytics that this can be, your revenue can be this much increased this year from each and every of these branches attributed to your company's revenue. All this information I can get to data warehousing. But still that also has its own problems because it's kind of maintaining this one is a problem. It's a system where it can be this also cannot be kept at a single place. I mean, I can even multiple data warehouses are possible still. Okay, I can have a data warehouse at USA, I can have a data warehouse at India, all those things. But the data can be populated into that data warehouse and giving a unique data at the entire output of a report. That's still not possible through data warehouse. So then there comes the traditional distributed system. So a distributed system is going to have your data distributed across the geographic location. Like I can have my same data, whatever the Chennai data, that can be available in US as well. The US person who can see the Chennai data. The Chennai person can see the US data. Wherever I'm sitting, I want to see the what is the company's revenue on the US branch. I can still sit here and I can see that. So that's what the data has been shared across in a distributed system. But that also has still having a own problem, like network latency. Like, I mean, the integrity of the data that cannot be maintained because the systems has to transfer the data from one end to another end through a network. If the network card has been broken or there is any slowness in the network, then your data might not be the latest in different branches across. Okay, so that's the problem in the traditional distributed system. So then comes the big data. So it collates all these essential problems, whatever the other database systems or the other models that has, all this has been put upon into a technology that's called as big data. Where you can do analysis on the data, whatever is being fed through, and it can be easily shared across different geolocations, and it can be stored in an enormous way, like whatever your data warehouse is doing, and it can do a collection of all the data, either similar data or an asymmetric data, all those things you can do. And also a huge volume. You have a coordinator who can check on this. I mean, the people sitting on the waiting room, because I'm getting this message triggered every time. Somebody can help me on that?
Sure, sir.
Okay, thank you. So that's how this big data pitches into the technology. I mean, pitches into the market into the 2000s. So where I can do a research on a data pretty easily, and I can get the visualization report immediately on a in a huge volume of data. So that's how the evolution of data comes from 1916 to the 2000s. Okay, I'm moving to the next part, which is the introduction. So what is a big data? It is a phrase. A big data is a phrase, or we can call it as a methodology that actually describes how you are acquiring the data, then how you are curing the data, then how to process the data and store it in a humongous volume. So how to acquire, in sense, what? I mean, it's going to acquire the data from different endpoints, different systems, heterogeneous systems. It's not a homogeneous systems. It may be a heterogeneous systems. What is heterogeneous systems? I may get a data from a 1980s Windows system. I can get a data from a Windows 10 OS operating system. I can get a data from a mobile. All those things can be acquired in a single place. Then cured. What is cured? It is going to process the data and eliminate all the duplicates. It is going to get only the data whatever you are going to require. So that is curing the data. Process it. It's going to transform the data, then how you want to visualize it. That's what processing. Okay, then store the humongous volume. I mean, I have a 10 million, 1 million, or 20 billions of data that is been flowing across different systems. I want to store it, and I have to do all these operations: acquire, cure, process. So all these phrases comprises of big data, but this all happens within a stipulated period of time. That is a real time. If you take the database or relational database or warehouse, all works on the past history. I have to store the data, then you will go and collect the data, then you will do the processing. This is how it happened till now, until the big data comes into the history or into the picture. But this big data is going to help you in a real-time fashion. Like when you put a data immediately, that's been transformed into something else in a real time. Not only a single person. I talk about the 2 million or 3 billion or 10 billion of data being processed in a single second. The real-time fashion. The transaction has been complete. That's what I'm trying to put it here. So that's actually not handled in the traditional systems. It cannot be happen on RDBMS. It cannot happen in a data warehouse. It cannot happen in a distributed system because it has its own disadvantages. Like it cannot have the integrity. It cannot be present on multiple systems, or it cannot be present on the multiple locations, or it cannot be a tabular format, or it is going to allow the duplicates. All those things are there in the traditional systems, but all is being eliminated through the big data. Okay, so if you see here, then I can get a different kind of data from a different format. I can put a data in a PDF. I can put a data in an Excel sheet. I can put a data in a notepad. I can put a data in a XML. I can still process all this data in a specific time. Okay, many companies are going to put a data in a different format. I can collect all this data. I can process it. Then the other thing is like how this large sets been analyzed and what is being it is being used for. All this being cured and processed to it is going to give you an analytics on what kind of data patterns we do have and what kind of the human behavior that can be associated with this data and what kind of interactions you are kind of making it onto the data. All these things being sufficed with this big data. So this is what a big data. So big data is a complete methodology to acquire, then cure, then process, then store in a humongous volume of data at a stipulated period of time. Okay, that's a frequency or the range of time it is going to do all these operations on your data and present it across. That's what the advantage that big data is having. Okay. So next, the types of data. So both like man-made and machine-made. That's what they have. Segregated it. If you see here, there is a business process data. What is business process data? Like whatever you have it in your database. Like you have your college database where your students or your college professors or lecturers go and log in and do some operations. Like you have all your systems being associated, your lab systems being associated with the username and password. All that is being stored in a Microsoft Active Directory database. So where you just go and log in with your username and password. But after logging in, you've been doing a different activity, human generation of data, where you will create a file, where you can put an email, where you can create a weblogs on the system, where you can go and log into your Facebook and do some sharing on the Facebook posts. Then you can do a tweet. Then you can go and watch the YouTube videos. All this kind of human interaction you're making in a particular system, and you're generating a huge volume of data. If a single person is doing this kind of data, think about when a class of 50 can how much kind of a data that can generate, right?
Sir, excuse us, sir.
Yeah.
So sorry for the interruption. Some of the students are willing to join, sir. Kindly admit them, sir.
I hope I am the host. That's why I'm giving this message.
Yes, sir. I don't have that.
You can have yourself as host and allow me to share it. Because I'm getting this pop-up every time.
Yes, sir. Sir, can you make me as co-host?
Yeah.
Yes. Thank you, sir. Thank you very much, sir.
No problem. Okay. So can I continue? Okay. So the volume of data, once you enter into your system and you've been making it, give me a second. Still people are asking. The volume of data that you're entering into a system and you're making is like like a logging in, and because of you are logging in, there is a log generated on the system. This person is logged into this system. So that is a log. That kind of data is being generated through a human interaction. But the business process data is like you have been logged in with the data already available in the system, right? I have a user list in my Microsoft Active Directory that allows everybody to log into their system in a particular domain or a network. That's a business process. That kind of data will be a 1x of size. Okay, if you take your college, you may have around 2,000 students or 3,000 students. So the record would be of 2,000 or 2,000. 2,000 or 3,000 would be there in the database. So that is a 1x data. Through the data, you guys are logging into the system and you are making a humongous amount of volume of data that you're generating. That is a human interaction. That will be more than 1x, that is 10x of data. From there, if you're going to the machine, it's a complex data where kind of a satellite imaging, then sensors, video, CCTV footage videos, recordings, then weblog files, then kind of bioinformatics, all this were the machine-made data that you are not going to generate it. The machine is completely generating it. If you take a satellite imaging, I can give you an example over there. Do you know the weather forecast, right? All these satellites are sending the images continuously without a second. It is going to stop it. It is going to send it continuously. That data would be a complex data, and it will be a huge amount of data. That's 100x of data. They do want to have the data stored in a different kind of data store and data warehouses it cannot have a single database or like your PC or something else. It should have a different database, entire database server rooms. They have to maintain it. So from that server rooms, that kind of 100x amount of the data would be generated over there. How I can read those data and process it, and I can give you a better forecast today. That has to give, right? I have to give it. So that all can be only possible through the big data. So through these types of data, you can see like clickstream events, then device logs, photos, videos, then geo satellite data, then your data that you've been started to source it from your web, like social media, then your FB or Twitter trending on certain topic or something else. That's a sentiment analysis can be done. Then product campaign. I'm going to promote something else. Then I'm going to share it across to the different people, and I'm going to put a banner in the Facebook. This kind of data I'm generating in the Facebook. If you see Facebook have a huge volume of users across the world, right? So they do have a business process data, then human interaction data, then machine-made data as well. Okay, so these are the types of data we do exist in, and this 100x kind of data can be only processed through big data in a real time to get the visualization of data what you want to see. Okay. So now, why big data? So each and every industry having a problem with their own challenges on the data. Like what I mean, if you take a bank, we do have yearly we do have only one bank or two banks in India. Now, if you see around 32 banks are private banks or government banks we do have in the India itself. So if I want to transfer something else from my account, from my bank to a different bank to a different person, it has to happen in the moment of time, and that transaction has to happen over the network, and the data has to be stored. Like I have debited some amount from my account and credited to somebody else in a different account. So this can happen between two persons, and think about the 32 banks and the customers of 32 banks. It can happen across in a the whole day or in a single one hour of frame of time. If it is happening in the real time, how a bank can find a potential fraud in this transaction? Somebody can hook that particular transaction and they can swoop in the money for their account. So to avoid such things, they have to analyze the transaction streamings, the logs generated by our transaction. Like I am going to send a money to a B person in a bank, then there will be a transaction log would be generated. So those logs will be analyzed by the big data in a real-time fashion. So without such kind of analysis, I cannot identify such a threat or fraud, potential fraud. I mean, if there is no big data, think about it. Big data is doing the processing in real time. If there is no big data, think about it. What would happen? The data, whatever I am doing, the transaction, everything will be stored in a database. Then next day only I can go and take the database and I can analyze all the data. The fraud would have been happened by the time itself, right? But I cannot find that fraud. Next day only I can find that potential fraud or potential theft that has happened. So there is no usage of seeing that on the next day. So we need to see it on the real time, then only I can alert the customer, right? If you're making a transaction on a swipe on a card in a particular shop, and if the particular limit is being exceeded, you're immediately getting a message, right? Your limit is being exceeded, or you are trying to use the card, or somebody else is using your card. If not, kindly contact the bank. Such kind of messages are coming across, right? How that is possible? They are real time, they are doing the processing of the data. Think about not only me, if think about a case of 100 persons doing a swipe across. Think about a 1 billion or 2 billion, 3 billion people doing a swipe across. How I can analyze? A single person cannot do that. So that can be done only through the big data. Okay. The same goes for the energy usages. The petrol or the gas or oil, crude oil, everything. So usage across different countries. Many oil wells are spread across different countries. So many distributors bought those oils from each and every companies. So they want to compete with each other. How they can compete with each other? They have to know where the oil usage is huge. How they can get to know in a real-time fashion? Then how they can beat their competitor? It's all happen only through the big data. They can gain the data. If they do it tomorrow, then some competitor would do the real-time fashion, go and have an upper hand on the business. Then the same case for the product promotions and everything. So I am trying to do a product promotion today, and I don't know how that reach to the people right now. If I don't know it, I know only by tomorrow, then there is no usage. By the time other product would have been launched and they would have done it. I'm trying to put a sale of a mobile in a Facebook or something else. I want to know the status and the sentiment analysis of that particular sale of that mobile. How many people have brought that? You could see a message and news as like, yeah, the mobile has been that has been sold in 2 minutes when it's been opened up. How they know in the 2 minutes it's been sold? They are processing in a real-time fashion. So these are all the kind of big data technologies where it is been required. Okay, and if you ask me, sir, okay, why can't we have this big data in our college itself? It's not going to be useful because only it's you do have a database of only 2,000, right? If you are trying to do that such kind of big data on a real-time fashion for your college, it won't be helpful because it is going to process a huge volume of data. With the 2,000 persons details, it's not going to do such a thing. It will take time. It will have a performance hit as well. So that's why it is going to only work on the humongous amount of data. That's what I stressed already in the in my first slide, like big data introduction. I said it's a humongous volume of data is required to process. Okay, where and all this humongous data would have to be generated in a social media kind of thing, in the internet, in the web, you can see such kind of data, or in a big, thermal power stations or big machineries that would generate logs, big embedded systems that generate logs across the world. There, the big data is required. Okay, so this is where I can say the big data is required. Then if you see the size hierarchy, how this has been grown, you can, this has been really a terrific thing. I mean, when we starting our career, we do have a floppy disk which comprises of only 125 MB of data. Then comes the CD, which comes with 512 MB. Then comes the DVD, which comes with 4 GB. Then comes pen drive, which is a reusable, ROM.
வாங்கிருங்க பின்பக்கமும் எதுவும் இருந்தா அவன்கிட்ட வாங்கிருங்க. ஆனா இந்த இதெல்லாம் கிடைக்காது. அந்த நாட்டு சக்கர ஒரு வேலை இருந்தா அங்கே
Can somebody mute it?
வேற எங்கேயும் ஆன் ஆகும். நல்லா இருக்கும். அதுக்கு அதனால நீங்க அங்கே வாங்கிருங்க. அது மட்டும் வாங்கி
Can somebody help me to mute that? Thank you. So now whatever we speak only in GB, right? Because all the mobile companies, all the companies, everybody, they are offering only data in GB. Nobody is saying I'm going to give you data in a MB, right? So we refer to only the gigabytes now. So the gigabytes consist of 1024 MB. Now this 1024 GB called as 1 TB, that is terabyte. Nowadays, a lot of laptops are coming with 2 TB or 3 GB, and there are a lot of external hard disks that you find it in the market with 4 TB, 5 TB, right? That's a terabyte. So from there,
Hello, sir.
yeah. Am I lost?
No, sir. It is not audible for a short. Hello.
I've been getting muted continuously.
Okay, okay, sir. I only try to mute the participants. Sorry, sir.
No problem, no problem.
Okay.
Okay, where I missed it? From terabyte or petabyte? Okay, let me go back to the petabyte. I mean, think about the terabyte. I mean, terabyte is of at least you do have a hard disk now. Right now, external hard disk that you find your 2 TB terabytes, right? Such kind of 2 TB terabytes in a 1024 TB. You think about it. So how much that hardware could be? So from that 1024 petabyte, it's going to be an exabyte. From there, you're going to see the zettabyte. Now people are dealing with the zettabytes for the big data processing. The yottabyte we are yet to reach, that is ZB, 1024 ZB, that we are yet to process that yottabyte. But still people are processing on the zettabyte. It is still there. This kind of data still exists in the world. Okay. So this kind of size hierarchy we've been reached now. This kind of size of data that we have been generating daily in our day. Okay. Next, that's what I want to give the statistics. You can see that here, and everybody can read by yourself also. I can read through also. So big data statistics, if you see 6.4 zettabytes. I mean, and one more thing to state that this data is being taken from 2008. This is not the latest one anyway. If this kind of data in 2008 in a normal situation, this kind of data has been generated. Now we are in a COVID situation. Everybody at home, everybody have a mobile, everybody have a laptop. People are working from home. Think about the situation. How much kind of data we've been generating across, right? So 6.4 zettabytes of data exist in the digital universe at the date of data to 2018. Then the data is been doubling every 2 years. That is 90% of data. Think about it, 2020. How much data we've been generating during this COVID-19, right? Then Facebook stores, accesses, analyzes 30%, 30 plus petabytes of user-generated data. Think about it, 30 plus petabytes. So it's a humongous amount the Facebook is generating across. Then Walmart. This is a retail. What I can say, it's a grocery store where it has more than 1 million customers in 2018. Now people are not even going to the shop, so they do generate the online groceries. So that has a transaction every hour, every minute. They do open the sale, they do start for the data. Everything happens. So in 2008 itself, they have 2.5 petabytes of data. Think about 2020. Probably we would have reached the yottabytes. We don't know, right? So more than 5 billion of people are calling, texting, tweeting, and if you try to decode our human genetics, right? It will take 10 years to process. That kind of data is being stored in each and every gene of our human. Okay. Then they say about AT&T database. So how much data they do have it? They own it. Like largest volume of data in one unique database. That is 312 terabytes. They do have it. And the second largest number of rows in a database they do have is 1.9 trillion. That's not an ordinary number. We do have it in every database. If you have it in a small database of your system would crash. It cannot survive that kind of data. Okay. Then how much the rapid growth of the unstructured data is going on. I'm talking about a structured data here. These are all structured data. Structured data in sense like Facebook users are a structured data. I mean, I have a login, I have an account in a Facebook. That's a structured data. But the data you're generating through Facebook is an unstructured data. I am trying to put a video, I am trying to put a text, I am trying to put a smiley, I am trying to put a photo. All these are unstructured data. The data, the structured data is only your user account or your profile. That's it. But beyond that, whatever you've been generating, that's all unstructured data. So how much kind of rapid growth we do have by the time of 2018? You can see that here. So the YouTube users are uploading 48 hours of new video every minute. Okay, nowadays everybody has a YouTube channel by themselves, right, at home during this 2020. Then they're saying 571 new websites were created every minute of the day. Now I don't know, it may be more than that. So brands and organizations on Facebook receive 34,722 likes every minute. Then 100 terabytes of data uploaded daily to Facebook. 30 million pieces of content shared on Facebook every month. So think about the data. Even the MRI, MRI scans that you guys go and do it. So it is of high resolution data. That is a 215 million of data being generated through the scans. You've been going for the hospital and everyone recommending to do a scan. That is generating a 215 million per day. More than 200 billions of HD movies. So these are all big before the Amazon Prime and Netflix and everything comes in. Think about the Tamil rockers and everybody is putting across the data, right? So they are saying they do have 200 billions of HD movies. For a single person to watch, it will take 47 million years. So that kind of data we do have here. So these are all kind of a different structured data. All this data I can process it only through big data in a real-time fashion. It has its techniques. It has its own tools that can do that. Okay. I'm going for the next slide. So then real big data and real business issues. What kind of business issues if you don't have the big data? So we can see like many companies, the volume of business data, if they don't, across every branches they do have, doubles 1.2 years because of new customers joining in, and they do have it. So if they want to maintain such kind of data, they need to go for the big data because they do want to process the unstructured data with their volume of businesses getting increased. Then if you have the poor data, if you don't have the data that's been transformed or cured properly, they are in a situation to lose their operating revenue. The new users would not come. If the site is pretty ugly, it is not performing good, if the site is loading very slow, then you won't go to the site, right? Really, we don't have this kind of speed, Mbps or any kind of speed. Really, we do have only KB in the speed, internet speed. So that time, each and every site would load very slowly. In that time, if you think about big data, that's not at all possible. So now you have the speed of transferring data through networks that's been improved, and it helps to generate their revenue in a big fashion. Okay, and also a bad data, poor data quality can cost a business annually. I have the data in India, something else, and the data is not yet updated in the US. I'm seeing yesterday's data, then I'm going to end up in a loss because the data has been updated in India, not in US. So these are all such kind of informations I'm putting it across here. Like according to the executives, the IT infrastructures are going beyond to put all this data into their hardwares. So it has a big strain on the hardwares, IT hardwares. Then in the same survey, they are looking, many small companies are looking at the big data as a big business opportunity to curate, process the data. And many companies of decision makers thinking to bring this big data as to their storage systems to get their visualizations and to process the data in a real-time fashion. All those things happening across. Then we do have technologies that's been at the back of the big data, like what I can say, Internet of Things, then enterprise mobility, then we do have DevOps, then we do have cloud computing, we do have AI, artificial intelligence, everything. All these latest technologies are being into the big data's backbone right now. If you see Internet of Things, I mean, IoT, right? This has been represented as IoT. It's been generating a humongous volume through what and all kind of way. I set up an IoT in my home for a TV, for a light, for a fan, and all this been connected to a Wi-Fi, and I have a mobile that's been connected to that Wi-Fi. So all this I can operate remotely, but still the data has to be generated from different devices, right? Fan is of a different company, TV is of a different company, and my light is of a different company. All would generate a different data, right? So all this data I have to process it and I have to give a report to my mobile. All these items are switched on or off. How I can get a visualization of all these things? It all represents a different data. So there you see the big data to transform the data for me. So not only the home, I am saying as home as a simple example. If you take as different thing, agriculture automation, then if you say smart cities, then the telecommunication area, then even you can monitor your kids and parents, and also you can set up a motion sensor on any particular track anywhere. All those things would generate a humongous volume of data in a different format and the heterogeneous sources. I can do that for this Internet of Things. The big data can do that. Then if you come for the enterprise mobility, you can see a mobile recharge. I am trying to do a mobile recharge now. I want to get that recharged immediately, not tomorrow. If I do it today, it has to happen today. So if you think about how many persons do that at the same time, how many persons do the recharge at the same time, how many persons going to do the withdrawal of cash from an ATM. When I do a withdrawal of cash from an ATM, I'm immediately getting a message, right? I have an SBI debit card, but I have n number of bank ATMs right now, right? So each and every bank ATMs would generate a different kind of transaction log. I can go and put a ATM in an SBI ATM in an Indian bank. That would generate a different transaction log to the bank. I can put a ATM in my SBI ATM kiosk itself. That would generate a different transaction log. So all these transaction logs I can generate immediately in a very faster manner, and I will reply to you that this much of amount is being debited from your account, and you have access to this ATM. How I can give all this information in a real-time fashion? There comes your big data. All these things are playing on the back. Then next, cloud computing. So what is cloud computing? Cloud computing, you don't want to own the hardware by yourself. Okay, you can just go and buy the hardware that's been offered over the cloud. I don't want to own it myself. I don't want to do the maintenance of the hardware myself. I can simply connect to that hardware from my local laptop, and I can run a big company, right? This maintenance, then performance of the box, and increasing the database of the box, increasing the hardware of the box, increasing the speed of the box, all this can be taken care by the cloud companies. So a lot of cloud companies like Google Cloud, you have Amazon Cloud, you have Microsoft Azure Cloud. A lot of cloud companies are there. They do maintain the hardware and everything, but for yourself, you don't want to do anything on the hardware maintenance and anything. But for maintaining such hardwares or increasing the performance of such hardwares, they have to monitor each and every logs generated by the hardware, right? Then only they can immediately help you to increase the RAM or increase the your hard disk size, or the request that you make on your particular system. All those things has to be captured, right? It will be stored in a different data source servers that will be stored in a separate location. How I can get to know? So they do have this big data in place that will collect all these logs, that will accure all the data, curate, transform it, and give it to you, so that these machines does not have the required hard disk or required performance. You just have to go and increase the RAM, or you just go and have to increase the hard disk as such. Okay, so that kind of information have been only processed through big data. It can in a real-time fashion. Okay, Then comes the DevOps. So DevOps, what is DevOps? It's a development operations. I want to develop a particular piece of software, and I want to have it a client server setup in my local PC. I can do that, but I do want to modulate across in 100 systems, and I want to run it. That can happen only through the DevOps. It cannot happen through a single system. So for the DevOps also, still we require that big data to process these 100 systems data and collect it, collate it, and cure it, transform it for you. Okay. Yeah. So now comes the characteristics of big data. What are the characteristics? It has around seven V's. That is volume, then velocity, then variety, veracity, value, then visibility, then variable. So the main components or characteristics I would say is like volume, velocity, veracity, and variety. Other things are of attributed characteristics of big data, not the main characteristics of big data. So volume, here you can see huge volume of machine and man-made data. Like I am trying to go and click on AFB or something else, that historical data I'm trying to keep and maintain. And I'm trying to maintain the bank transaction. I made it for 2 years or 3 years, still I'm maintaining it. I can pick you at any moment when you ask for it, right? So all these things are huge volume of man and machine made data being stored across. That can be processed by the big data, that's a volume. Then velocity, the speed of the data that is being generated, captured and processed. That's what I can give it here, that geospatial data, your weather data, then your tweets that you are making instantly. And I want to see what is the toppest trending tweet, how that can happen. Everybody is trending on something else, and I want to go and see the trend, what is the highest trend of tweet, how I can do it in a real-time fashion. That happens through the velocity, speed of processing the data. Then variety. Variety is unstructured data. Different devices generate different data in a different format, different files. All those things can be taken up and structured by the big data. That is variety. Veracity. Veracity is the trustworthy of data. Whatever the data I'm getting is a true data, or it is a duplicate of data. Is the data is an accuracy? All those things will be comes under the veracity. Then comes the next attributes of the characteristics like value, visibility, and variable. So value, return of investment, right? What is the return of investment? I am trying to put a data in a Facebook or in Amazon or anywhere. I'm trying to brandizing a product. I want to know the negative and positive feedbacks on that particular product. So that's where I can get to know what kind of investment I made, what kind of return I'm going to get out of that particular piece of product, right? So that can happen through an ROI, value. If I'm getting an ad about a product, then you visited an Amazon, and after you coming out of Amazon, you are getting an ad when you try to launch any other website. If you try to click on that particular Amazon ad and you go through the process of Amazon site and you add it to the process of cart and you buy it, then I got the return of investment, right? If you are ignoring that one, then the product is not liked by you. Why the product is not liked by you? I want to get to know it, right? That all these click streams, with the click streams, I can get to know how much people have been ignored the product, how much people have been went and add to their cart. All those informations I can get to know through this value, how that is been achieved through big data. Return of investment, I can get to know if this product is going to sellable or not. Then visibility, visualization of the report. The same thing, take the value, return of investment. I'm trying to visualize how much bad reviews I got it, how much good reviews I got it, how much this product is being purchased in the immediate launch, how many ignored that purchase launch at all. All those things I can get through a visibility in a meaningful visualization. Okay, that also happen only through the big data while processing it. Then variable data varies from size to size. I mean, initially I would process only 1 million of data of a particular company. Then when it is been I mean, it has been increasing its size and venturing into a different stream. Then I have to process that data as well. I cannot go and change the big data. Hey, I am going to expand my company, so you have to change by yourself. You have to add something else more to you. I cannot do that. The big data is a big data processing. It will do the methodology even you try to increase or expand your business. I am going to have that such kind of technology techniques that would process the data, even if you expand it. So that is variable. Okay, so these are the 7 characteristics of big data. So whenever somebody else asks you what is the characteristics of big data, you can say these 7 V's: volume, velocity, variety, veracity, then value, visibility, and variable. Okay. So next item we are going to see the tools. What are the big data tools? Hadoop is the major tool that's been used to process your data and everything. But still, there are different technologies and data are there that would allow you to engage with the big data to cure it or process it or acquire it or transform it. All those things happen through this kind of tools. Okay. First one is, I can say, Spark. So this would do a in-memory computing with low latency, SQL solution. All these things are completely a technical jargon words. I cannot put it in a place in a simple way. So this is one of the technology that could do the low latency processing of data. Low latency in sense, I mean, it can do it in a very faster manner of acquiring the data from the in-memory. It loads the data from different sources and store it in an object-oriented format. The way we speak already, right? OOP model. This would do that OOP model and acquire all the different format of data and collate it and transform it for you. That can be done from the Spark. Then MongoDB. This is also a document-oriented database. I mean, if you see a database, always will be a table of rows and columns. This MongoDB is not a rows and columns. It's completely document-oriented. I can store the data in a document fashion. I can still use this MongoDB to process the document. If anybody knows about the JSON, that is JavaScript object notion, it also processes that data. Early we do have XML as our notion for the internet. Now we do have JSON as well. Okay. Then TD-Aster. TD-Aster is a Teradata. This is one of the tools that's been used to perform the map reduce. Map reduce is one of the techniques in big data. What is map reduce? Map in sense, I want to get different heterogeneous and homogeneous data from different sources. I will acquire all the data and I will create a map for it. This is going to be the mapping for this kind of data from different sources. So all this data would be going through that map and collect only the data I wanted. Okay, that is what called as map. I will map all the data, what is required. Then I want to reduce it. I don't want all this maps, whatever acquired from everybody. From that map, I want to transform the data and I want to give a visualization. That will happen only through the reduce technique. So there are mapping and reducing technique in big data that can be achieved through all these tools. That is TD-Aster. Then cloud map reduce. Then Amazon EMR. Then Microsoft HD Insight, IBM Big Insight. Then we do have a Disco. So this is a lightweight framework used for the distributed computing, and it's been used through Python language. Okay. Then comes MISCO. This is for mobile devices. This also supports Python. Okay. So these are the other tools that I can highlight, and there are many other things like we do have Hadoop, we do have Kafka, we do have many items on the tools of big data that can do anything that you don't need to lay your hands to do any coding. You don't need to write any SQL queries to lay your hands and process all this data. There are certain kind of commands and configurations and techniques that is being followed in big data. With that, you can achieve all those things. All this framework has been written already. You don't need to write anything newly. Only the logics behind that, how that can be achieved. That alone you can write it. All the processing of mapping, reducing, transforming the data, all those things will be taken care by the tools itself. That's been already written. You are going to use the techniques and commands, configurations. That's it. Okay. So this is what an introduction I can give it to everybody. This is what the an intro on the big data. Hope I didn't code with this my session, or I didn't try to bring on more and more computer jargons here. So hope it will be useful for you guys to understand this one, where I can give light a shed on what is the big data. Even though it's been released long back, many doesn't know what it is big data. Still, people come and ask, what is big data? Why do they call it as big data? So just to shed a light on it, what is this technique or technology is all about. So that's it from my side. Thanks everyone for staying. And if you have any queries, you can put it on the Q&A.
Thank you, sir.
Yeah.
We have two queries, like how secure is this big data? We have a query on this.
It has its security layers being added to each and every the frameworks of big data. So it's not like what I can say, the secured socket layer to connect it, and you do have the what I can say, different security techniques being followed inside. Encryption and decryption of data when you've been trying to process the data. So all this being acquired over there, but in the network protection that we cannot ensure it. Other than that, whenever we try to process the data, we ensure the security of the data with the encryption and decryption technologies. That's been still in one of the part of big data that is there.
Okay, sir. Then we have another question. How to secure personal data?
How to secure personal data? This is out of big data, it seems. I mean, you have a lot of wallets over there. You can secure it. I mean, I didn't understand this exact context. I mean, how to secure personal data. I mean, each and every tool provides you the privacy settings for you to secure your personal data, right? I mean, even your WhatsApp, even your Facebook, even your Google, everything helps you to secure your data by yourself. You don't need to, open up all. Whenever you try to access such an applications, you have to just go to the privacy settings and you go and see there. There you have lot of options to do your privacy settings as well. You don't want to annoyingly give all your data to the companies that is going to follow you back. Okay, every data is being taken from all your click streams through your browsing, through your internet. I have opened my Gmail in a separate tab, and I'm trying to access the web data from that website. Still, they have a lot of options to go and collect your Gmail records. But Google has provided a lot of securities to stop that. But still, you do have a lot of securities being added to the Google that you can itself define for yourself. For the Facebook, I hope many would have been done that. I mean, like Facebook, WhatsApp, you have a lot of privacy settings, like you don't want to put your photo, you don't want to put your status to anybody, only your friends and contacts. Such kind of settings you can make it yourself on the applications or apps you've been using. And if you try to use your different apps on your mobile, you have to be very sure on giving a allow whenever you try to install it. Think about it double time and you have to allow that. Otherwise, your personal information will be leaked out. Okay.
Okay. There are some questions in the chat box. Can you please answer those, sir?
So, 109.
It's like which tools used for big data in fraud detection?
No, it's not like a separate tool to detect a fraud. Okay.
Okay.
It's been a processing the data. There you can find the fraud. That finding the fraud would be that there can be any tool, but in the big data there is no fraud detection tool. This is going to generate a data and process it for yourself to find the fraud. It is going to process it for you in a real-time fashion. That's what the big data. It is not going to detect the fraud. It is going to present the data to detect the fraud. Okay, that's what the technology. You should have your own tool or script, anything else that can go on directly. I mean, I cannot say the bank, if I'm trying to snoop into the network and yeah, I'm trying to scoop out a transaction log or something else and get the data, how do I know that this has been, the way that the fraud can occur? That I cannot do, only the bank could know that. So the bank could ensure that have a fraud detection system where I can feed the data in a real-time fashion. That fraud system cannot hold data that cannot be in the past. It needs the real-time data. That real-time data processing can happen only through big data. That's what I'm saying here. So don't confuse with big data and fraud detection, because big data is not going to do the fraud detection. It is going to transform your data for your fraud detection tools.
Okay, thank you, sir.
Yeah.
Another question, sir. If big data had not existed, which alternate technology would have carried out the same?
I have shown you the evolution of data, how there is no other technologies. Big data is a technology too. It's not a what I can say. It's all about the techniques that's been done by the different tools. Big data is a phrase. It's
Okay,
not
that
a
is
tool. It's not a tool. That's what I'm saying.
okay.
Okay. It's a phrase where I have shown you the tools that is been associated with the big data technology. There is no other technology that can do the processing. This is, if you go and ask me what is object-oriented programming language, if there is no object-oriented programming language, what would be the other thing? There is no other thing, right? It's a complete design. Object-oriented programming is a model. It's a design model. Okay. Like that, other tools, whatever you are seeing there, that are the languages that's been associated with object-oriented model, Java or C++ or anything else.
Okay, thank you, sir. And here I take immense pleasure to propose vote of thanks. I, on behalf of IQAC and Departments of Computer Science and Computer Applications, extend a very hearty thanks to Mr. Satish Kumar K for rendering a wonderful webinar session on Big Data Introduction. Thank you so much, sir, for your valuable time and effort, and wish you all success in all your endeavors. I thank our management, principal and vice principals for their support to make this event a successful one. I thank all the staff, whoever have contributed, and all the participants. Thank you all. And participants, feedback link will be provided in the chat box now. Please provide your feedbacks. Thank you.
Thank you, everyone. Thank you very much for joining this one. Very much happy to be part of this one to help the students understanding about the latest technologies. And I've been given this opportunity. I should thank everyone for getting this opportunity. Thank you very much.
Thanks again, sir. Thank you so much.